So we already defined the FEM file. The next step is to define the SIM file. So earlier in the FEM file, we defined the cross section of the beam as well as its meshing as well as the material properties. And now in the SIM file, what we will do, we'll define the physics of the problem, which is will define the kind of loading the problem the beam will be having, and also the constraints or the boundary conditions that will be applying on this beam. So under simulation file view, again we'll shift from FEM file to SIM file. So you can double select the SIM file, or you can right click that and make it make work part. So you can do either of that. So now you will see, so this is what's known as the ribbon band. So the options that was there earlier has changed. Earlier you had some meshing options here, and then you had option where you can define the beam collector and everything. And now you have this folder here, which is loads and conditions. So first let's define the boundary conditions or the constraints on the problem. So if you go to constraint type, you have user defined constraints here. So we'll select user defined constraints. You can name that. So as we said that the left end of the beam has pin support and the right end has a roller support. So we'll first define the constraints for the pin support. Right. So the left end here is represented by a node which will be there, node number 1. So in order to select that node, what you have to do, so just beside menu there is this type filter. So we'll just select node from there, and now we'll be able to select the nodes on our model on the screen. So we'll select node 1, which is the left end of the beam. Now the pin support or the pin joint will allow this beam to bend about the z-axis, but it will constrain all the other motions. So for this problem, degree of freedom 1 to 5 has to be fixed and 6 has to be free. So we'll first go to all fixed, so it will fix all the degrees of freedom, and then we will individually free the degree of freedom 6. So this is the pin support here. So if you zoom in, it will tell you the cross is representing the translation degree of freedom, the circle is representing the rotational degree of freedom. Again we'll apply it to the right end. So this time it is roller support. So we'll select the node on the extreme right end. So make sure the type filter is node, and you will have node 61 there. So again we'll first make all fixed, and then we'll keep 1 and 6 as free, because this is roller support, and roller support allows the movement along the longitudinal axis, which is the x-axis here. So this translation about along x-axis is free, degree of freedom 1, and degree of freedom 6, which is the rotation or the bending that's happening about z-axis, is again free. So degree of freedom 1 to 3 are translation x, y, z, and 4 to 6 are the rotations. Again we'll press OK. So we'll see here under beam model solution, you have two constraints, pin support and the rotor support. The next thing is to apply load. So as we can see here, the load is 5 kilonewton per meter. So usually the load is in the units of newtons or kilogram force and all, but this is load per unit length, which is how the load is applied on the beams. So again, if you go to the simulation file and if you go to load type, so generally we'll use this option to apply any kind of load force, but since this load is load per unit length, so we'll use pressure here. So if you go to pressure, again you will see that the units are megapascal, which is normally the units that are used for pressure, but you can change the type to on beams, and the units will change to force per unit length, which is what you want. So we'll select the object first again, and since we know that the vertical axis is the y-axis and we are applying a load in the downward direction, so we'll use the y component and we'll give it a value of -5. So since in the presentation you saw that the loading was 5 kilonewton per meter, but here the units are newton per millimeter, so I'm applying -5 here because kilonewton per meter is equivalent to newton per millimeter. So again, if you select OK, you will see these arrows that will represent the load that is being applied on the model. And again, under the static load one, you can see the pressure load option. You can rename it if you want. You can rename it to uniform distributed load. So so now this is everything that we had to do in the simulation file. So our simulation file is complete and we can go with the solution. So a good way of doing it is to first see if you have defined everything correctly. So in the beam model solution, if you right click, you will see that there is an option of model setup check. So what it will do, the software will just check whether the setup is complete or did you miss anything in terms of maybe you did not define the material or the loads or constraints or anything. So we'll do a quick setup check, and there are 0 errors and 0 warning. So you can close that, and to solve the model we'll go into this solution folder and select solve. So you can check or uncheck the setup that you already did. Make sure the submit is solved and just press OK. So this is the information window that tells you that Neston file is created, and since the problem is very small, it took a couple of seconds, so the solution is complete. You can close all those windows. So in analysis job monitor, if you select this file and if you go to analysis job information, it will tell you that there are no errors or warning. So now the problem is solved.